Hello friends, in this lecture we are going to know about some system and system properties. So it's system and system properties. So what basically system is? It's basically the physical process or device that generates an output when an input is applied to it. In form of a equation, if we have to denote a system, it's something like this, that yt is equals to t, and it depends upon x of t, where t is used as a common representation of system. In terms of an input output, your output input relation, and if we have to draw a block diagram for it, then it will be x of t is applied as an input to a black box or a box or the device, and corresponding to which we receive an output yt, and t is basically your system which reacts to the input xt to provide output yt. Now, the system can be of many types. A system can be with memory, memoryless, it can be a causal and non-causal system. Non-causal. So we are going to learn them one by one. The first one is your system with memory and memoryless. Now, so if we talk about the memoryless system, the memoryless system is when output depends upon present input, or basically we can say it doesn't depend on the past. So we can, in terms of equation, yt is proportional to x of t. Like we have a voltage and at an instant t is proportional to, or can say equals to, r of it. R is a constant. In a similar way, for discrete time domain, yn is proportional to x of n. Now, if a system is with the memory, system, or you can say system with memory. is one which depends on present or past, present and past, or only on past. Means the system can be a combination of input which depends upon past and present both, and one of them, or we can say not one of them, the past only on past. Then it is a memory, a system with memory. So you can say y of t is proportional to x of t minus k, or yt is proportional to combination of xt minus k with xt. It can be, if I say combination, it can be addition, multiplication, or division or subtraction. So, but the thing is that it depends upon, or is proportional to both of them, your xt minus k and xt, or it depends only on past. Next one is your causal and non-causal system. Causal and non-causal system. In some books or at some places you will find that non-causal is also written as anti-causal system. The causal system is if output depends on past and or present state, then it is a causal system. Present state of input x of t. So yt, if I have to give an example, yt is equals to t. Another example is yt may be equals to x t minus 1, or yt is equals to maybe equals to xt plus x of t minus 1. And the main thing on which it should not be depend upon is future. So the output, which you need to remember, the main thing is output does not depend upon future values, or you can say time instants. Then it is a causal system. Anti-causal or non-causal system. Non-causal or anti-causal, when it depends on future values of or time instants of input signal, then it is a non-causal or anti-causal system. So example of it is, suppose I'm taking an example now in discrete time domain, that it is given to you that yn equals to x upon x of minus n. Now if I put any negative value, so if I put n equals to minus 2, then y of minus 2 is equals to x of plus 2. So from here you can see clearly that present value depends upon a future value, means the output value which is at minus 2 depends upon an input value which is at plus 2. So with respect to, in terms of time, t equals to minus 2 is past, or you can say here in this case it's present, and the present depends upon future value. In the same question, if I put n equals to 2, then y of 2 is equals to x of minus 2. In, for you can say the positive side, you can see the present value, present time instant depends upon past value. I'm saying again here that for y of minus 2, the present depends upon future. So this yn equals to x of minus n is a non-causal or anti-causal system. The reason is that when it's on negative side, the present depends upon future. So these are the main properties of system. There is some more properties with respect to stability. So what is stability is that if you are changing the input slightly, or the change in the input it is small, and the change in output should also be small. So for instance, if I have, it's given to us that yt is equals to e raised to the power mod of xt, and xt is given so you can say the xt is restricted, or you can say xt is bounded. Then for the system to be stable, the output should also be bounded. So we call it as Bibo stability, and it is bounded input and bounded output. Then if we are basically then saying is that if we are applying input which is bounded, then my output should also be bounded. So in this case of yt equals to e raised to the power mod of xt, if my input is restricted between these two values minus 2 and 2, my output is restricted between, you can say, e raised to the power, or you can say your output yt is less than e raised to the power 2. So in this case the output is restricted And the reason being, how my output is, the input is restricted between this. So this is Bibo stability. Now the another example is, if you remember that there is a string to which a ball is attached, and you start moving it in one direction. So what will happen is that this ball will try to come to this side, and then from there it will move to this side, and from there it will try to move to this side. So there will be oscillations about this midpoint. So you can say your input is bounded because you are giving a small power or the force to the ball by which the string is moving on both sides, and the ball is coming back every time to its mean position and going up to a certain height and then coming back to the mean position and then going on the other side. So the input provided by you is bounded, and due to which there is a small movement in the ball, you can say the output is also bounded. Now consider the same case, that this ball is connected to a thread which is not very strong, and you hit it with a bat. So what will happen is that you will hit it with so much power that the string or the thread attached to it will break, and then the ball will take a path something like that, if you remember the physics behind it. And if you are hitting the bat from this side, then it will hit this side and the string will break from here and the ball will go in the air. In this case, because you are providing an input which is not bounded, so output you are getting is also not bounded. So you can say the system then in that case will be, system is not stable. Okay. Thank you for watching this video. Please put your questions in the comment box, and if you have any other queries, I will try to answer them whenever it's possible for me to answer. And please like, share, subscribe my channel. Thank you.